So welcome to the TensorFlow user group session, Mysuru session, and so yes, so we are conducting events every week, and if you want to be part of the core team, volunteering team of TensorFlow user group Mysuru, we are the second biggest community in India at the moment. And so if you want to be part of our community, you can reach out to one of our core volunteering members. There is one core volunteering members in the stream, Samuel. You can reach out to him, or you can also reach out to Nikhil or Kevin. And so we conduct events every week with top speakers. So if you want to keep a tab on our events, then you can go and subscribe to these meetup pages. And you can also follow me on Twitter for event notification. And there is an email ID of Nikhil here. You can actually drop him an email if you want to, and if you're interested in volunteering. And the community partners for this event is Co-Learning Lounge and Applied Singularity. Both Co-Learning Lounge and Applied Singularity has got amazing data science resources. You can download. You can download Applied Singularity Lab, Applied Singularity app, and you can also subscribe to Co-Learning Lounge if you want to keep tab on their resources. So we have 3 sessions today as a part of TFUC meetup. The first session is going to be taken by Shantanu Kumar, and he is a data scientist at LinkedIn, and he is going to talk on the topic domain-specific sentiment analysis. I'm handing over the session to Shantanu.
Awesome. Thank you so much, Usha. I'll just start sharing my screen real quick.
The screen is visible, Shantanu. You can go ahead.
Awesome, great. So thank you guys for, of course, taking out the time to attend all of these sessions. I'm starting with domain-specific sentiment analysis today, and a lot of you might not have heard of the domain-specific part of the sentiment analysis, but I felt that it was very useful to bring up and take a session on, because I believe sentiment analysis as a topic, as we're going forward in the space of natural language processing, I think it's become very widespread in that it's used almost everywhere that you can think about, from user reviews, point of view reviews, or even a lot of times, say, understanding sentiment for elections on Twitter, or a variety of things that a lot of users speak about, because one of the biggest and the most dominant ways of communication these days has become Twitter, or maybe a LinkedIn, Facebook, or something that's very textual in nature and not necessarily very voice-based or picture-based, or even I think a lot of those mediums. I think text has been dominating for a couple of years and is going to lead the way in, I think, social media conversations at least, which makes text a very powerful method and a very powerful, say, medium to be able to deliver speech and deliver, say, content, and even sometimes goes on to even hate speech or opinions or emotion understanding and so on. So sentiment analysis, of course, while I dive into this, I just want to run you guys through the agenda for today real quick. So I start with an introduction to sentiment analysis and what this really is for a lot of people who might not have heard of the term before, or might want to understand a little deeper in terms of what the field is. I don't deep dive into the specifics of sentiment analysis, but just as the top view understanding of where this field is going and what it does with the text. The second, I start with current alternatives and what their problems are. So what we have available with us, and where are the shortcomings in a lot of what is available with us already in the market. The third is, I think, a particularly specific topic, and and something that's very close to me and a very close favorite of mine is the hard classification versus, say, a spectrum based sentiment analysis, because I've always felt that sentiment and human sentiment, the way humans perceive emotion, is not the way we actually end up doing sentiment analysis in production, and in a lot of ways, even in projects, school projects, or even, say, algorithms that are running in millions and millions of users. I think that's a distinction I make there. The fourth point and the fifth point are both in unison. I think I'll run them through just to give you an understanding of what kinds of sentiment analysis algorithms we have, and how we can then adapt these algorithms to be more domain specific, in that be very structured and careful with, say, what kind of domain you're using sentiment analysis. And once I walk you through the current alternatives, you'll understand where I'm getting at with that. So I move forward. I think before I begin, a real quick introduction, and if there's anyone who wants to connect, you can please feel free to use the URL in the chat below on and in the deck below to try to connect with me if there's any questions you might have after the session and before as well. So I started off in the space, of course, when I was about 14 and 15, as a matter of fact, where I used to pick up a couple of things when my dad used to tell me some stuff about AI and data science back in the day. And this was almost a decade ago now. And I think a lot of things have not changed since then, and a lot of things have changed since then. So a mixture of both of these, I would say. But I think what's remained is that the core problem, the core reason I did pick up and join this field was because I felt there's a problem out here to solve with the kind of data that we collect on users and people, and you can make a lot of decisions based on this data. Is why I felt this was uh, a need of sorts to be able to join a field like this. I started my career with Udacity when I was doing analytics for Udacity India. Of course, before that, I was interning in a couple of places as well, but started off my full-time career at Udacity. Very, very interesting things we built out there. I didn't spend much time there, about a year or so, but ended up building some amazing things for the India business, and that was the first data science hire for them. I went on to do a lot of research on student performance prediction, how users use Udacity's platform, how they graduate with their nano degrees, and what kind of weeks do they feel a lot more stress in, and so on and so forth. So that was the work that I used to do at Udacity. I've always been very close to the space of education. I think that's been something that made me start at Udacity and also made me come back to LinkedIn. In between, I think I wanted to explore a little bit of my own passion with the field of AI and data science, try to understand what's going on in the field and how I can probably be on my own for once, try to understand if the things that I've been thinking about, the things that I've been building, even makes sense to a lot of people or not. So I switched from Udacity to a startup called Enfido, which I met at a tech conference when I was attending Tech HR in about 2018. And this was where I think I met Amber, which was our product, Enfido's product. And we were into employee engagement, trying to understand HR context and sentiment of employees when they're unhappy, disengaged, try to predict if they're unhappy or likely to leave the organization in some shape or form. And eventually, I think I spent about a year and a half or a little over that at Enfido, decided that it was time to come back to the education space. And that's something that made me move back to LinkedIn about three months ago. And this was where, of course, the entire globe of sorts had already shut, and I was switching my job and my role. So I'm based out of Bangalore now, of course, but I'm still remote for the rest of this year, I believe. But I work on LinkedIn groups as a product, and try to understand how users use LinkedIn groups, how they discover them, and so on and so forth. So that's what I'm currently working on at LinkedIn. Of course, a lot of experimentation, a lot of different things across the board. But I think these are, I currently own LinkedIn groups at LinkedIn. So as we begin, I wanted to give you guys 3 seconds to understand this statement. And I'll tell you why I particularly bring up two of these statements, and they're because I think from a sentiment analysis perspective, and I get to this a lot of times, if say a statement, right, my manager asked me to redo 8 out of my 10 presentation. Now, is this positive, negative, or neutral? I think you'll, if I give you 5 seconds to think about this off the top of your head, you will find that you will first struggle for a couple of seconds, then you'll figure out it must be either a negative or a positive or somewhere in the middle. You'll have a fair understanding by the end of 10 seconds. If I give you this one, you will definitely be sure that this is a negative. Both of these sentences, when you compare them from a natural language standpoint, right? Humans and language is something that's very complex and complicated in terms of computerized understanding, which means in our head we know what to feel about both of these sentences right now. But to a computer, is it really fair to be able to bucket them in one of these three? This may be yes, right? Like this might be a lot more straightforward than the previous one. But what matters at the end of sentiment analysis, and something that we start off with every time, is to understand that there is always a vantage point, which is what kind of viewpoint am I looking at this statement from? If I go back to these statements, my manager asked me to redo 8 of my 10 presentations. Now, this, of course, hands down, if I am someone who appreciated that feedback, I would say it's positive. If I'm someone who did not appreciate the feedback and I thought this is unnecessary, I would have said it's negative. And from a managerial standpoint, if my manager is not already annoyed with me, they will probably think it's neutral because they're giving me a little more to tweak, to work on, and so on and so forth. So if you think about it from 3 different vantage points, you will find that this one statement can have 3 different sentiments, but a computer will always give you one. Moving from vantage points, just wanted to give you a dictionary understanding of sentiment analysis, right? So this is what we just did with these 2-3 sentences, is my understanding of trying to understand what you feel about these sentences. When I say what you feel about these sentences, I mean, we'll get to the part where computers start to classify them in a particular bucket and so on and so forth. But the emotion that you feel in your mind when you first see these sentences is probably very different from what a computer will come to at the end of it. So if I go back to this one, which is why I brought up there is politics in our organization, because almost everybody hates politics in an organization, right? But what's surprising is that once we tag this as negative, we make sure that we only give it one viewpoint and not multiple, and not a different direction of sorts in a viewpoint. We only give it one particular viewpoint. In the same way, if we tag this sentence as positive, we only give it one viewpoint, which means it is very contextual from where I'm looking what the sentiment of my statement could be, or is, for that matter of fact. So sentiment analysis is broadly what we just saw. It is using techniques, right? Using mathematical techniques, modeling techniques to try to understand what kind of emotion is this particular piece of text or a particular piece of discourse or even an image sometimes is trying to depict. Uh, I usually, of course, most times colloquially, when the word sentiment analysis or the phrase is used, it is particularly used to refer to natural language processing. But of course, you can extend this field to a lot more domains than just NLP. But this is a way you systematically try to break down your sentence, try to understand what kind of emotions, what kind of information is present in this text. A lot of places where it's widely used, and a couple of examples off the top of my head I could give you is when people are trying to improve their products, they go out to social media or they go out to say forums, try to get feedback on what they did, what their product was, and so on and so forth. And across the board, I think it is not just with product improvement, but also customer experience and consumer experience at large. And this might be your conversations on social media. A lot of times people use open source APIs to try to demonstrate what's happening on social media about particular topics, about particular customers that experience a certain shape or form of understanding. And I think that's been a very wide use of natural language processing and sentiment analysis. And one of the broadest examples off the top, if you have to think about, could be the elections. And the elections, not just, of course, a particular country, but across the board, this influences a lot of conversation. And this in turn adds to the loop, which is, and why this says closed loop, is because at the end of it, you have to make sure your election results. And if I compare this to elections, right, uh, a lot of elections are narrative driven, which is why a lot of people use social media sentiment analysis summarizations to eventually feed back to the same narrative that began initially, which is, if I see out of candidate A and candidate B, if A is winning a lot, and if I put out there in social media and everywhere that, okay, A is winning, that further adds to the narrative that A might be the better person, A might be in the lead, and so on and so forth. And another place it's very greatly used, of course, is competitive competition intelligence, which is, if I want to try to understand how, so I have products on social media myself, but my competitor also has products on social media. So let me particularly search for the words that occur in my competitor's products, and then let's try to break down how people are feeling about their products. What is a place where their product is breaking down? And think broadly, just try to summarize where you are better and where your competition is wrong, so that you can use this information to eventually feed back into what you're doing and how you can do better. I want to take one slide, of course, to break down natural language processing as well, because a huge part of sentiment analysis is breaking down one dimensional text. And why this particular slide, and even though it might not be completely related to the topic that we have at hand today, but a very important one nonetheless, I believe, because this is something that should be ingrained in everybody who ever tries to do sentiment analysis or work with textual data, is that NLP is an AI complete problem. And AI complete, of course, is so if you've studied computational complexity and computer science, you'll understand there's something called an NP hard or an NP complete. And the same way, I think in 1987, the term AI complete was also coined, which is that if this particular problem is solved, that is when computers will become as intelligent as people, or maybe just a strong version of AI, right? Which is basically, an AI complete is something that it's not a one shot solution to anything, which means if I give you this algorithm and if I give you this problem statement, you will never have one particular solution that is completely going to satisfy all your needs. And that is what AI complete is. And why I bring this down particularly into our sentiment analysis and a domain specific sentiment analysis slide is because, and I go back to the first statement that I showed everyone, was that sentiment and human sentiment, human emotion, and textual understanding is very contextual to where you're looking from. If you're looking at it from a different viewpoint, it can absolutely change. And humans can know that very easily, right? To switch context, and it's called word sense disambiguation as well, if you guys want to read up on it a little bit, which is, in what sense was this spoken in? If you can solve for that, I think you can eventually solve for a lot of things that you're doing with natural language processing, because one of the biggest drawbacks and one of the biggest challenges that we faced with sentiment analysis and NLP as a whole is that there are so many different ways to come to one particular solution that you might never understand which is the right way to go about it. And which is what makes sentiment analysis and NLP particularly very hard. I want to jump into a quick nuance where I try to differentiate between how sentiment analysis is currently done versus how I've preferred it to do a lot of times, and how it is naturally designed to be. So, of course, before I dive into hard classification and spectrum-based analysis, I want to make sure that you guys know that you can feel free to ask me any questions during the session as well. If there's anything that you have off the top of your head that you didn't understand in the previous slide or in the slide that's currently on your screen or upcoming, please feel free to add comments and questions as they keep coming, and I'll be very happy to answer them as we move forward as well. You don't have to particularly wait till the end, but you can also definitely start, I think, whenever something comes to you off the top of your head. So with hard classification versus a spectrum-based sentiment analysis, I wanted to, of course, go back to the same statement that I started off with, which was sentiment is always going to be a spectrum to humans. Human emotions are very strongly spectrum-based emotions. But now you can never always use a spectrum to make business decisions at the end of it, right? Which is, I think, one of my mentors puts this very well when he says data science of sorts has to be supplemented very strongly with your business needs. Otherwise, I think a lot of what you're doing will fall apart, because you can't have one data science problem, one natural language processing problem, or something of that sort, and completely isolate it with what your business is doing, right? Because if I am, say, cloth vendor, or if I am in the manufacturing industry, or if I'm in a product design industry, and if I'm creating products, and if I want to understand how my users are doing, I can't necessarily put up a data science function and let them do what they're doing, because I need to I'm collecting data, and whatever data tells me, or whatever analysis that my data team say does for me in the larger scheme of things, they will give me an output, they'll give me an analysis, they'll tell me what's happening with my product, where I can improve, where I can go wrong, and a lot of those things across the board. And which is where your data team and your data functions have to be very closely knit with what your business outcomes are. A lot of business outcomes usually work, and at least in the sentiment analysis space, I've noticed, are very binary in nature, or very, and I wouldn't say binary particularly, but very class based. And then eventually all of the classes are plotted into one spectrum, and that's where they try to see, that this is a spectrum or something of that sort. But a lot of it by design is not spectrum based, whereas it is supposed to be. Because if I go back to this real quick, you will find that this statement has so many different vantage points. How can you put it into, say, one bucket here? It makes it very tough to find a particular bucket that you want to, say, fit your statement into. Because if I say that my manager asked me to redo 8 of my presentations, it might not be, say, a negative, or it might not be a neutral, or it might not be a positive. It might be somewhere very closely in a blend of, say, either a neutral or a positive, or a neutral and a negative, or maybe a different scale altogether. I think that's what makes sentiment analysis very subjective to who is looking at it, which is also why the neutral class, and if every time you try to pick up and understand sentiment analysis, you'll find that the neutral class is so widely used. And even when I used to do sentiment analysis with Infido before, we saw that a huge chunk of what we had in terms of our sentiment analysis, and we were in the employee engagement side of things. So I'll of course walk you guys through uh, what we used to do and how we used to gather feedback using domain-specific analyses. But before I dive into that, I wanted you guys to know that the middle bucket, which is your neutral bucket, is very dominant, because your machine learning algorithms and your optimizing algorithms are all based on the data that you provide them. So if you sat down to annotate this data, if you sat down to annotate this statement, you have so many different vantage points. So what you would do is normally put it into neutral, because you don't know what it feels like. You will say, let's go with neutral. And once you tag that as neutral, your machine eventually ends up thinking wherever there is a complex sentiment involved. Whereas There might be a lot of positive, there might be a lot of negative. Humans tend to bucket subjectivity into neutral, which is, so to say, a safe space, right? Because you're not taking sides of sorts in any way. And that is where sentiment analysis gets very, very tough to evaluate, because how do you evaluate sentiment analysis algorithms right now? A lot of people use, you can use very simple, straightforward precision recall AUCs, or even accuracies for some measures. And accuracies right now go up to 95, 96, 94, and those are mind-numbing accuracies, because that is very, very high. Whereas even humans aren't that good at understanding sentiment. Off the top of my head, I don't feel that humans can be that accurate at understanding how people are feeling or what people are talking about, because there are so many complex emotions involved in a human, which is what makes it some sort of an AI complete issue. And I want to show you guys one quick thing before I move forward. This is the Stanford Core NLP, and this is where I think I will touch up on this real quick before in a while as well. But you can always access Stanford Core NLP using corenlp.run, and you'll find that if I tag sentiment, and there's a lot of text I can annotate here, you can put a couple of things, and you'll find that you'll get a sentiment for them in a particular class, say a positive, negative, or a neutral. So if I press submit right now, my text to annotate is my example on top, which is the quick brown fox jumped over the lazy dog. Now, what I want you guys to think about is, of course, I'll hit submit in 5 seconds, but think about what this could be. To me, this looks neutral. And this is what I was talking about, right? So there's a lot of algorithms out there that are judged basis not uh, complex measures, but very bad metrics. And here, if you try to judge the Stanford Core NLP, which is supposed to be one of the the pioneers, Stanford NLP and the Stanford AI Lab is one of the pioneers of AI and data science research, has tagged this statement as negative. And a lot of times you will find that uh, very, very different, and I'll come to those parts of the sentences outside as well. But this statement is something that we've been learning as kids, and this we never knew had negative connotation. But again, the kind of text it was trained on, what had happened to it before training, so on and so forth. I think so many factors to keep in account, that you'll find that this statement was not supposed to be negative at all, but has been tagged negative, which is where a lot of sentiment analysis normally fails. I want to give you guys 10 seconds to just check out these examples that you have on your screen. And I'll walk you through each one of them one by one to try to understand first, the same way that I tried before, to first try to answer these yourself, try to understand if there's a particular emotion or sentiment you feel about them. And once you know that, we'll eventually go to different algorithms now and try to see how they are subjectively analyzing these statements, right? So you can take 2-3 seconds. My cat is beautiful, but her paws are dirty. This again, complex sentiment involved here, because one part of it is positive, one part of it might be negative to someone. I think that's where you'll find uh, it tough to bucket of sorts. My food is tasty, but it's too hot. I dislike the weather. I like sunny days. I do not dislike cabin cruisers. I love my mobile, but I would not recommend it to any one of my colleagues. So a lot of these I would call complex sentiment. And if I try to pick out one of these, right, let me just pick this out and put it on Core NLP. Try to understand what's happening on Core NLP with this statement. So again, my cat is beautiful, but her paws are dirty, is a positive connotation. And of course, a lot of people might have a lot of uh, say different opinions on them. If I change the pause to face, does that change anything? It clearly doesn't. My food is tasty but too hot. I'm not going to analyze all of the statements, but I just want to show you that common sentiment analysis techniques today will try to find the neutral bucket as something that is like a it's like a fallback for them of sorts, which is if I want to be politically correct, right? If I don't want to take sides of sorts, I will find myself picking one of the neutral buckets. And that's something that sentiment analysis uh, does not do very well, because there is complex emotion involved here, and it does a bad job at understanding complex emotion. You see, all of these have come out to be neutral except for the first one. We used to have at Infido, we had a 55 to 60% neutral ratio. I think this has taken a long time to run. Way up, this is also neutral, as you can see. So what I wanted to demonstrate again is that while you see 4 out of these 5 examples that I've put out for you guys to see, and of course I didn't try them beforehand, but just off the top of my head right now, is that 4 out of 5 here are already tagged as neutral, which naturally tells you that neutral seems like a huge fallback of sorts for a lot of people trying to not take a side with sentiment analysis, and that becomes a huge upheaval of sorts in a lot of ways, because we want sentiment analysis to function in a particular way. And now, of course, we'll explore if you dive into a particular domain, right? If you say, I want to be a part of the HR domain, I want my sentiment analysis to be very well with the HR domain, not great with the general domain. Or if I want my sentiment analysis to capture election emotion very well. I think a lot of these things can be captured across the board with specific sentiment analysis algorithms and not general ones. Because as I just showed you, 5 of these and 4 of these are neutral. So neutral seems like the fallback. And one of the worst things with neutral sentiment is that it's not worth much analysis, right, to you or your business or to anybody that's using this data. Because what do I do with the neutral sentiment? There's nothing I can act on particularly. So I quickly deep dive into the types of sentiment analysis that we have now. And of course, a variety of types, but the 2 broad ones that I will touch up on are lexicon-based and corpus-based sentiment analyses. And of course, I might not be able to show you all the code for this, but I will definitely show you a little bit of code for the lexicon-based analyses. And the 2 broad aspects of sentiment analysis, right, the way that you can do them. One is a dictionary based, and which is called a lexicon based. And the example of that is Sentiment R. Sentiment R is, I think, one of the best libraries and algorithms that I've ever used for dictionary based sentiment analysis. It was developed by Tyler Rinker back in, I believe, I think a good 5-6 years ago. I think he's been very kind to have been updating quite a bit of it as we speak. But a lexicon-based sentiment analysis is, of course, one that you have a dictionary and you have these particular words that you can assign scores to, right? And by scores, I mean you can do a 0, 0.1, 0.2, 1, 2, 3, 4, based on the kind of sentiment you want to assign it. And then eventually, when you assign words these scores, your sentence computes all of these words together, these scores together, and gives you a final output of a sentence. And I'll show you some examples as we move forward. But lexicon based is basically, say, happy will be a +1, very, like a sad can be a -1, and so on and so forth. And even if you go into very hardcore dictionary based rules, you'll find that phrases will also have terms, right? Like a very happy can be a +2, extremely happy can be a +3, and so on and so forth. So when you start to add all of these, If I say I am very happy today, very happy is the only sentiment bearing here. I am and today are not sentiment bearing, so they'll all have zero. So when you and this is something off the top, very vanilla based approach. If you add all of the scores in a sentence, you will get a 0 plus 0 plus 0 plus 2 plus 0, which will give you a positive score at the end of the sentence. A corpus based approach to sentiment analysis is something that we just saw with the core NLP, which is you pump a lot of data in with a lot of pre processing, feature vectors, and so on and so forth. I think a lot of you might be very familiar with the corpus based approach of sentiment analysis. Spacey uses, and NLTK, I believe, uses corpus based approaches as well. Core NLP is built on a huge corpus. I'll share some of these resources with you at the end of the deck as well. I think you can research and find some time to go over these. But broadly, these are the two ways to go about it. One, and if I have to give you a very easy summarization of these two techniques, one would be where humans will infer word-based sentiment, and one will be where humans are inferring statement level sentiments. I think that's the only broad difference between the two. You have to tag all of these corpus based sentiments. You have to say that this sentence is positive, this sentence is negative, and then you eventually break those down into feature vectors, try to run a classifier on this, and so on and so forth. Both of these techniques can eventually be aspect based and non aspect based. And I'll give you an example of what I mean by aspect and non aspect based. The bed in the city hotel was not comfortable. However, the breakfast was excellent with good food and service. We had a wonderful time and we'll travel with Travelito again. So this is my example of an aspect-based sentiment analysis, which is if I have to break out and in one sentence, humans can speak about a variety of things, right? They don't necessarily have to speak about only one thing every sentence, which is the perfect example of the fact that as you can see, the underlined words in this or the underlined phrases in this entire sentence are the ones that are called aspects. And by aspects, this is basically one portion of your entire sentence that can have a different sentiment than your entire sentence, which is the bed in the city hotel was not comfortable, but the breakfast was good and they had a great time with this particular travel industry. So you'll find that you've broken down this into three, and one part of the sentence is positive, one part is uh, bad, and one part is positive again. So that's how you've broken down one sentence into three different aspects. I'll start to break down lexicon-based and corpus-based approaches with some pros and cons and kinds of keywords that you should keep in mind. I particularly for lexicon-based analysis want you guys to refer to if ever you spend some time exploring this yourself. I would recommend you spend time on Tyler Inker's Sentiment Hour library because he lexically breaks down these words into particular word forms. There are four types of word forms that lexicon-based sentiment analyses can always have. One is called the amplifier, which is particularly not a sentiment bearing word, but increases the polarity of your sentiment bearing word, which is say the food is very, very tasty, and tasty is what is sentiment bearing here. Super is what is going to amplify my taste. So my sentence sentiment is going to be amplified by super. Detoners are what reduce the polarity of the sentiment bearing word, and I've underlined it on the right as well. Negators are something that reverse the polarity of that in a particular window size. Say, for example, I'm not feeling great today. That not will be changed and amplified into a particular, say, your great is your sentiment bearing here. And eventually you'll find that once you reverse it, that entire sentence becomes negative. Adversative conjunctions, and this is a particularly interesting lexical form. You will find here that your sentence is going to be only capturing a particular form of, say, sentiment. If I say I got great marks in my test, but I'm not satisfied, and off the top, you'll find that I'm not satisfied is the larger aspect of this sentence. Again, just uh, just something off the top that you guys should know is that lexicon-based approaches are very, very customizable, but most definitely not the best to use. They are white boxed for sure, and they're very, very good. But if you don't have the need to explain to someone how you've come to a particular sentence, then lexicon based solutions aren't the best ones to use, because they are low on performance, because they're hand picked sentiments. You can't naturally always know every word in the dictionary to be able to tag that positive or negative. Before I jump into corpus based sentiment analysis, just want to address some comments on the chat as well. Uh, I think one problem that was noticed is when you use, I think this was a comment probably on the satires of sentiment analysis as well. I think your service is good too good to be true. I got it delivered after 5 days instead of one day. I think Chaitali, you make a very good point there, because if you're ever using these sarcastic terms or these satirical terms with sentiment analysis, the kind of corpus it was trained on will always break off, right? I think that's one of the big problems with uh, these corpus-based sentiment analysis, because even with some very prominent Twitter accounts like Indigo, I believe this recently happened with Indigo's Twitter handle. Someone left their baggage went to a different city, and they went to a different city, and they thanked Indigo for it, and Indigo said thank you for thanking us, and I'm glad you had a great service. I think that's where a very, very true comment. I think that's a very good point to make. I think that's where a lot of these approaches with corpus-based approaches break off. And Kiran, again, your point on attention-based models such as BERT and LSTMs of sorts that have a problem, but attention models like BERT don't have a problem. I think off the top, if I have to think about it from a from a person not in the domain, right, I would find that it will definitely be a problem with all sorts of models that you use, because your models are very data based and data backed. And as I mentioned, I think sentiment analysis is a AI complete problem, which brings you into thinking that it will always have these accuracy mismatches here and there. Of course, I think BERT will perform a lot better because of a lot of technological advancements that BERT has brought through. But of course, not at human grade sentiment. And I'm not sure a lot of people even hold AI accountable to. I think that's where the disconnect with the industry is that people expect these intelligence formats of sorts to uh, always confidently be human level. And if they're never human level, right, people make fun of them on Twitter or on Facebook or wherever. Where I think we need to understand that if there ever is a strong AI, it necessarily does not have to be human like or human value centric or understanding sentiment in the same way that humans do. I think that's one thing you can keep in mind off the top of your head. Now that I mentioned it, I think I wanted to recommend a book to you guys who are listening in as well. It's called Super Intelligence by Nick Bostrom. I think he details it very well. And I'll dive into that at the last part once I've covered my content. But moving on to corpus-based analyses, right? I think they are a very, and why I don't break them down particularly is because they are very straightforward in their approach of positive, negative, and neutral. You have to tag them. You have to every time you want to build a domain-specific sentiment analysis solution, you need very large volumes of domain-specific data, and you need to keep collecting models. You need to keep collecting data, and so on and so forth. And that's where I think corpus-based approaches with domain-specific analyses don't work as well. As Deepak puts in the chat as well, you can tag satirical comments or even sarcastic comments manually as positive, negative, or neutral. And you can try to solve your problem using these. They do help in a huge way. They do help in a great way. But a lot of times the problem is with the generation of these comments, right, Deepak? So even though they might help to a huge extent, they don't completely solve your problem. Um, and why that is true, because how much data can you generate for sarcasm, right? There is always another way to, you know, do wordplay. Like there's always ways you can move around your words, say something here and there, so on and so forth. And I think one of the biggest problems with sarcasm again is that there is not enough data that is very specific to the sarcasm domain. So you have to generate it, handpick it, make sure you're annotating right. And one thing just wanted to put out there for you guys is that hand annotations with natural language processing are a problem in itself, because there is something called the multi-annotator problem in NLP, and which is where if I go back to these sentences, right, look at your screen, and if you try to understand, if you pick 5 of these statements and if you ask 20 people, you will find you won't get the same answers every time. You'll get different answers. So your model is only as strong as your annotation outputs, right? And if you have multi annotators, you are again breaking off there, because if I ask everyone who is attending this session today to annotate these 5 sentences, and if I combine all of those, you will find that uh, everybody's viewpoint is different, because they have all been they all come from different contexts, they all come from different scenarios of the world, and they are not necessarily going to be understanding sentiment in the same way, and everybody is objective in that. And I think that's where the problem with multi annotation comes into play in NLP as well. I now start to introduce the domain specificity of NLP, and let me just address a comment in the chat as well. Um, so Chaitali says that one way is that the sentence is actually negative, but the person is telling that it is a good adjective. The model can detect it as negative. So I think off the top, that's something that I was mentioning again as well. Google's bot Mina understands a lot of great things because of the volume of data that has gone into it. And a lot of AI innovation and data science innovation these days has not become intelligent innovation, but data pumping innovation, if that makes sense. Because if I have hundreds and hundreds of thousands of textual understanding, textual comments, I will have enough of data, right? But say not always. If you're doing a project, if a lot of you who are attending the session today might either be in university doing your degrees, trying to get into the field, start off in the field, be experienced in the field, or be a thought leader in the field, right? There are a lot of personalities that could be attending a session, for example, in any given session at any given time. Now, if I take a huge sample like a Google who's building Mina, they have that kind of data. But who else has that volume of data? Maybe Facebook, LinkedIn to some extent, Instagram, WhatsApp. But what about everybody else out there? Nobody has that kind of data to make those solutions, which is where a lot more innovations in terms of algorithmic changes come into play. And I don't deep dive into the algorithms as much, and particularly sentiment analysis. I mean, there's 2 algorithms I introduce. One is the SentProp, and one is the LexCore algorithm that you guys see on your screen right now. So these 2 algorithms help you contextualize your domain. And by domain, I mean, and let me just give you an example of what I mean. If you can see my screen right now, I type there is politics in my organization on Stanford Core NLP, and that gives me a neutral sentiment. Whereas I know for a fact that this is not neutral. This is supposed to be negative, right? Because politics in any organization is bad. So why is this giving me a neutral output? Which is why that brings me back to my statement of uh, a lot of these algorithms will try to avoid taking sides when they don't have a clearer answer, because a lot of people might have, and this is stemming from the same bias that humans will have when annotating this data. Because I will find that if this is not hand annotated, this might be public domain, and that kind of labeling gets even tougher. Which is where the SendProp algorithm, and I've given the code and the paper link for you guys to explore in your own time as well, uses some random walks, and this is a mathematical technique to try to understand how uh, a particular word is used in a particular context in a particular domain, and how that can change when you switch domains is what this nprop algorithm does broadly. So say for example, big men are very soft, which is in the sports domain, versus in a 2x domain, which is a different domain. For example, if I'm talking about pajamas, when I talk about pajamas, soft actually makes sense, right? It might be positive, like it's good to have soft clothes. But big men are very soft is something that's very negative for sports, because if you call a sportsman or an athlete soft, that usually looks bad on them. And the LexCore algorithm is something that I worked on. So this is an algorithm I authored myself, and you can find the code and the link in the bottom as well of the deck, which I can put up for you guys as well. Is I first try to understand what kind of context my word was used in, right? So I use standard word embeddings and cosine similarities, transfer learning, to try to understand what other words were used with the new word called done. So I'll give you an example. I start with the word done, which is not a word that I have in my domain right now. I don't know what done means. I don't understand if I'm using it in a positive connotation or a negative connotation. The same way I was using politics in my organization. I don't know if that's good or bad, but I of course know that for a machine I might have tagged it as negative, and for myself I might have tagged it in a different way. Which is where if I start off as a machine, I don't understand what done means. The closest word in my embeddings to done is damn. So I pick up damn, I take the score for damn, I check in TCM, and of course, I'm just giving you a very overview walkthrough of the algorithm, and you can spend some time trying to explore this as well. But I check what are the top, say, n words, n semantically similar words. I take all of their word vectors, try to uh, order them in a descending order based on how they're occurring in my text. Because if darn is occurring with damn and holy a lot, I think those remain the top of my words. Then I pick out, say, noun based or any adjective or a noun based word that was a similar word as my previous statement. I take out sentiment for those words as well, use the multiplier to multiply to that, and then just do an averaging to come to a final score of 0.25 positive for done. And of course, I think this is a very overview understanding of the algorithm, but just wanted to give you guys a view on what exists in the domain specific and how to switch your domains with sentiment analysis as well. I want to show you a real quick piece of code right now. And this is a slide I've left blank because I want you guys to think of all of the use cases that you can think about in terms of domain specific sentiment analysis, right? Because by domain specific, I broadly, of course, mean any type of sentiment analysis that can be applied to a particular domain and can function there very well. And by domain, I mean HR, tech context, education context, where some words might be very general to a lot of people, but in my particular context, they make sense. So let me show you a real quick example of some code that I was writing for this class earlier. So if you can see my screen, if you guys use R, and this code is on R. So if you're using R, I think that's you can directly use this code to pick it up. But if you're not using R, I think you can get a fair understanding of what I'm doing with this code. I first want to show you what a lexicon-based system looks like. So if you can see my screen on the left side here, you will find that I have words and scores attached to them, right? A board is positive, a bot is negative, above average is positive, abrasive is negative, abrupt is negative, and so on and so forth. So you have to label these dictionary values first and say politics is not in this dictionary right now. But if you want to add politics to this dictionary, you can particularly pull down this dictionary and in R add an extra row to this and say politics is something that you find negative in your organization. You can add a negative value to it, and you don't want to understand, if you don't know what value to put to a particular word, you can use one of these algorithms. You can either use the lex score or the cent prop to try to make sure that your politics word gets the right score for it. Try to pick out the right valence shifters. 1, 2, 3, 4 are basically negators. Adversative conjunctions are 4. 3 and 2 are 2 is basically a downtoner and 3 is an amplifier again. So if I try this on a bunch of text, right, I'll find that my first sentence was, I haven't been sad in a long time. So how this is working is I first pick up the sentiment bearing words here, which is sad. This is not. So this reverses the polarity of sad and that becomes positive again, and so on and so forth. So I think that's how it's broadly functioning and working on. And I want to leave this slide on for you guys to just as a summary, as a something that you can look at off the top to try to understand what kind of approaches are present with sentiment analysis and where domain specificity can be brought in, can be put into the picture. And these are some data sets that you can check out as well on the left. I've highlighted some of these. NLP Progress is a website that I definitely want to make sure you guys check out. It has state-of-the-art natural language processing updated. I think it was last maintained about a week ago, I think. It has everything that you will ever need with sentiment analysis and NLP and domain specificity. So all of these algorithms are something you can explore as well to try to understand where and what use case fits your domain the best. And again, you'll find that every time you're trying to switch domains, if you're trying to do HR tech, you'll find that there is politics in my organization. All of these terms will not work very well with general industry based algorithms like a core NLP or something. But you can use one of these algorithms that I've mentioned, either the lex score or the cent prop, to try to make your data very particular to your domain and your vantage point, so that sentiment analysis works very well for you. Because with sentiment analysis, the key is getting the vantage point right and nothing else. So again, want to open it up to any questions, thoughts you guys may have. Very happy to take any questions you might have off the top of your head. I also want to keep open my introduction slide. So if you guys want to, since I'm almost out of time, if there's anything that you guys have off the top of your head, you want to ask me, you want to say ask a question or need some feedback or advice on anything, please feel free to drop me a note and I'll be very happy to connect with you and try to answer anything I can that I won't be able to right now as well. So yep, any questions, very happy to take them. And thank you so much, guys, for spending an hour on the session. Of course, if I have to close off with anything, I do want to make sure you guys are safe and taking care during this.
You have a question, Shantanu, one of them.
Yeah.
Are you able to see the question?
Is it the can any RL algo work by Chetli?
Okay, the question is, can we tag these satires manually as positive, negative, and perform oversampling of these cases?
Okay, got it.
Yeah.
So I've answered most of the ones on top. I think I took Deepak's question in the session as well. It can help you to try to understand to fit your domain in a particular way, but not always, because you will never have enough sometimes to be able to keep tagging sarcasm as you keep going forward, because you as humans you'll always miss out on certain aspects of tagging.
Yeah. Okay. So if you have taken, Deepak's question, have you also taken Chaitali Deb's question?
Yeah, I think that's the last question that I haven't taken, which is, can any RL algo work? So again, Chaitli, just to say close off on that question and that note, is this is not algorithm based as much as it is human context based, as I said as well. your algorithms and your data pumping to a particular aspect can solve for you in some shape or form, but is not going to help you reach the kind of human level or domain specific level understanding that you're trying to go to. So I think that's if you want to use, if you want to particularly make sure you do your domain very well, I think one of these algorithms is what should work well for you. RL will get you a little better, but not your solution or what you're looking for.
All right. Thank you, Shantanu. You've got excellent feedback from the audience. They loved your session, and thank you so much for joining us on Saturday and delivering a great session. Thank you so much.
Thank you so much, Usha. Very glad that I got to deliver this.
Yeah. Thank you.
Thank you. Bye.
Yeah. Bye. Joinal, can you share your screen? The next speaker we have is Joinal, and he is going to give a hands-on demo, hands-on session on transfer learning with TensorFlow 2.0. So Joinal, your session, your screen is visible, and you can unmute yourself and go ahead with the session.
Thank you, Usha. Uh, Thank you everyone for joining today. Like as Usha mentioned, like I'm Joinal Ahmed. I work as a data scientist at a health tech firm called HelloDoc. We are based out of Indonesia. About me, I currently work again as a data scientist at HelloDoc, but I had been working with several other startups, Leadix, Cognitive Machines, and Sigtupal. These are on like I have a quite experience in health tech domain and also automobiles and like e-commerce. Apart from this, I also speak at a lot of events, these webinars. I'm also writing a book with Pact and Manning Publication. Apart from that, I also help startups to devise their ML strategy, how they should add machine learning or data science into their products, how they can use this technology in improving their product. So this is also I have mentioned my contact information. If anyone wants to need any further help about this session or anything in general, you guys can contact me. With this, let's jump on to today's session, like today's topic. Today we'll be covering up transfer learning with TensorFlow 2.0. We'll be handling like how do we handle custom data sets, restore backbones with Keras application API, and like restoring from disk. How do we add the model checkpoints and early stopping mechanisms? So I have mentioned this Git repo here. This repo contains all the all the codes required for today's session. So anyone interested to reproduce this this session can clone this repo. With this, let's start with like the agenda for the day. Transfer learning. Transfer learning is something very similar to what we do in normal life, right? We what do we do? We whenever we're trying to do something new, we refer to old research papers so that we take the knowledge from the other researchers who have done some work, so that we don't have to do that work again, and we can build on top of that. Similarly, right, transfer learning, we take a model which is already trained, already generalized well for a solution. So we take that model and tune specific parts of the model, or take specific parts of the model and build on top of it to fit another solution with this. Yeah, the example can be like same domain, different task, or maybe like different domains, like model trains on different domain, but the same task, right? A object detection model which is trained for say cats and dogs can be used by some other company who is into who are into like animal detection, and then add few more classes on top of it, and then they can train their model. Similarly, we can utilize these models to achieve different tasks. And yeah, uh, while talking about transfer learning, one major thing comes up is fine tuning the model. Fine tuning, there are like three broad approaches. What do we do to train a model? What is feature extraction? What we can do is we can take a model which is already trained and use that model, removing the last prediction layer, and use that model as it is to like to extract the features from them, because the model is already generalized. This can capture all the low level features, and we can use that to predict like we can use those features downstream in our model to either classify or maybe do other things. One classic example is we have seen models like faster RCN and fast RCNN, right? It uses a pre-trained CNN. Ideally, this is a VGG based network just as a feature extractor, and then we have the region proportion layers on top of it, on top of it to identify what are the objects are there, what is the bounding box and things. Other approach can be use the architecture of the pre-trained model, and then we can also do like we can freeze some layers of the model and then train the and then rest of the model as it is. So this diagram here, this can give you a brief idea about what to do when you have like what to do when like on different situations, like when the data similarity and the like when data is not similar, but also you have very less number of data, you may want to tune the lower layers of the pretend model, and you have a very high similarity, and also the data is very large, right? You can just fine tune the pretend model. So this like we can keep this diagram in our mind when we are approaching the transfer learning problem. Yes. So today for this session, we'll be using a data set called Stanford Dogs. So I've just added these snippets in the presentation itself, so that it is visible to everyone. So this snippet, right? The first step is that we download this. Second, just a second. Yeah. So once we download this model, the data set, the next step is to prepare the data, the pre-processing functions, right? First step is always to like read from their path and then resizing them, data augmentations and all, right? So let's start with this. So here like first step is like we define what are the height and width of the image, maybe the number of channels, classes, etc., and the learning rate, scheduling, and everything. And then like there are simple pre-processing steps that we are doing, right? What we are doing is like we are decoding the images, we are adding data augmentation. So this page, right? We are from the CSV file. What we are doing is we are first like taking all the paths from the images, and then we are converting them to TensorFlow's like TFDS format, and then we can like once we have the data loaded and converted into tensors, we can go ahead with training the model. So the first step would be yes. So like after this step, you can see like these are the example images that we have in our data set, right? There are various pictures of dogs, various breeds of it, and the data size is what 224 cross 224 cross 3, and the batch size that whatever we define. Now the step is like first thing what we'll explore is how do we restore a backbone from Keras or TensorFlow 2, right? So TensorFlow 2 or Keras, it provides the model like as it is in the backend, so we don't need to like clone other repository and then work with it. We can directly call this model which are already there in the library itself. So in this step, what we are doing is from Keras applications, we are loading ResNet model, which is already trained on ImageNet. And also remember that to write this, right, include top equal to false. So what it do is it will skip the top layer during restoration. And also, since we won't be training the previous layers, we'll set that all the trainable parameters in the model to false, so that when we are fine tuning the model, we are not actually altering this model, but we are only training the layers which we're adding later. In this case, we are adding these three custom layers on top of it, right? On the model, like one dropout layer, one dense layer, and a average pooling layer. And then once we do this, so you'll see here, yeah. So this tape, right? So once we load the model, we add these classes, and then we again like a simple how do we do in TensorFlow, right? We compile the model, and then the model summary. You see here we have the whole model from the whole ResNet model, and we have added one second. Yes, so we have added these three extra layers on top of it: average, pool, dropout, and prediction. And you can see the number of total parameters is very high, but the number of trainable parameters is very less, right? It is only what 2,41,880, but instead of this high number of parameters. So when we set include top equal to false and backbone dot trainable equal to false, what it does is it doesn't loads the like top layer during the restoration, and also sets the trainable parameters in the parent model or in the model which we are using to transfer the learning into a new model that we are building. So we won't train those parameters. And then like once we train this model, yeah, so once we train the model, we'll see that after 9 or 10 epochs, we'll achieve a testing accuracy of 75%, which is very high for a model with such number or less number of epochs. Then, so this is how we do. We restore a model from TensorFlow like Keras API, right? We can call directly. We can directly call the or directly load the model from the applications API that Keras provides. We have all the models available there. This is only example the ResNet, but we have VGG models available there. So we can call and we can pass these parameters to there, so that we can define which weights we want to download, right? Which the model we are downloading, on what data set it was trained on, and also we can pass here CFARNet or something like that, and also we can specify that whether we want to load the top level layers or not. And once and the other approach could be, we have a model which is already saved an H5. So let's say the example would be, say, now after this 10 epochs, you have saved this model. Now, after a point, let's say your requirements have changed, or maybe your model is not working well in a production environment. Right now, you want to train this model further. So in this case, if you do this same step, what would happen is you are again starting from scratch. But this is not what you want, right? You want your model to be starting from the current version. So what you can do is you can save this obviously when you'll be deploying this model into production, you will be saving this model into an H5 format. So here what we'll do is we'll again initialize this model similar way, right? We'll define that we want the model trained on ImageNet, and also we don't need. So here you see we have we have put the top encode equal to true. Then what we'll do is we'll say that we want to load the model with this whatever model we have saved in this path, and then we want to freeze the trainable parameters. And then the rest things are same. We will add custom layers. We'll tune the model, and then we can go ahead and training the model as it is, as when we want. There are any questions at this point, right? How do we approach this? Usha, if anything else. Okay. I guess no. Yeah. So one more thing we can do is, so right now what will be, if we go like this, right? What we'll do is we'll be only be able to save the model once it is trained. But there might be cases where you want to save the model at every epoch, at every iteration it does, so that you can use a particular weight at a particular epoch, as required. So what we can do is we can add a model checkpoint callback. What this callback does is it'll save the model at every epoch, like as and when. So we can define whether we want to train the validation accuracy or training accuracy, right? So whenever the validation accuracy increases, we'll save the model, and you can define like where you want to save the model and such things. Yeah. So the rest of things are same. What you can see here is we have defined that I want to save the model here at every time my validation accuracy changes, and also the like there are a few hyperparameters we can pass on, right? If you want to only save weights, so if you set this to true, it will only save the weights, not the model itself. So you can see here we have should be a folder. Okay, leave it. Yes, and then we can pass on. So at every epoch we'll be saving this model, and then again we can decide to save the final version as and when we need. Yeah. I guess Usha, where can we see if there are any questions?
Yes, Joinal, you had asked for something. Hello.
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 Yeah. Tell me.
Yeah, I'm asking, are there any questions at this point, because I cannot see if there are any questions.
No, I think so far there is no questions with respect to this session. So, yeah, maybe towards the end we'll get more questions. Yeah.
Okay.
Yeah.
Yeah. So next what we'll do is once we define this how do we add, now we know that we can so model checkpoint, what it does is we can define where we want to save the model, or also what do we want to monitor it, and we define and we initialize it in a variable. Next step would be adding it to the model and fit. So TensorFlow provides something called callbacks. You can list as many callbacks as you want. Maybe you can add a callback to visualize your training, like produce a real-time graph at each thing, at each epoch, or maybe run some other snip, or maybe push your code to some repository at each epoch. So you can add all those things, write custom functions for that, and list all of these things here, so that as for each epoch, TensorFlow will call those specific functions and execute those. Right now, let's say for this example, what we have done is we train this model for 3 epochs now, and we save, right? Let's say this example is, so we train this model for 1000 epoch, and then we save, and at some point we want to train the model from a specific checkpoint. We can do that, right? In TensorFlow, like model.fit, we can add a parameter called initial epoch. What we'll do is it will restore the model from that time, when like the restore the parameters at that point of time, or the epoch 1, and then start training from there. So in this example, you can see epoch, like training has started from epoch 1, but here we have started the training from epoch 2, because we have said that load the model at epoch 1 and start training from there. And again, another callback that what we can add is we can add early stopping callbacks, right? We can define that if my validation accuracy is not changing by minimum this delta, and patience, we can define that how many epochs we can take this, right? Let's say if I define 1, right? See, if between 2 consecutive epochs, if my validation accuracy is not changing, I'll early stop the model. But I can set this to say 10 epochs, 20 epochs, based on our use cases. And again, if we can add these callbacks to here. Yeah, you can see in this example, right? I have put the model to train for 10 epochs, but since my model is not changing the validation accuracy in this after 7 epochs, so I am saving the, like, stopping the training there. So this could also be this could also help us to not overfit the model, right? There might be cases where we have set the training to 1000 epoch, but my model have stopped learning at say 100 epoch, then my 900 epochs are extra. My model is just overfitting on the data. I'm spending my compute resource. I'm blocking my resources for maybe I would have changed some hyperparameters, train the model therein. Yeah. So let's go with the code example here. This was like overall theoretical aspects of it. Yeah. So let's start executing these so that we'll be able to explain understand it better. Yeah. 1 second. That time I
Joinal, are you done with your session? We're
yes,
not able to see.
yeah. By the time I just I thought I guess my environment like I have not installed TensorFlow in this environment. So by the time I install that, maybe I can take a few questions by the time it is done.
Okay, okay. Yeah, there's only one question by Prakasha Jensen. Can you explain the best use case of this learning?
Best use case can be today I have also delivered a session for upgrade. There we explained how do we use TensorFlow or sorry transfer learning to build quick models. So one use case can be, let's say you are training a model to train a custom to add one more class, right? So and you don't have a very less data points. So what you can do is you can use a model which is already trained, and since these model are state of the art models, these are very generalized. These gives out very like this captures very low level features, and then gives and the feature set it gives us is very rich. So you can use this model to extract the features from it. One use case would be, let's say you have a huge number of images, say in two classes like cats and dogs, and you want to classify or you want to cluster them together, like all the cats image in one folder and all the dogs image in one folder. And so that what you can do is you just take this model, extract the features, store them, and then use something very simple like cosine similarity, and all and cluster and based on these distances, like all the images which have similar features, store them together, and I can say like 80% of your images will be sorted. So that would be one example. Another could be let's say you are training a new classifier, and for that and for training the classifier again you don't have much data. So taking the example from here, you guys can see my screen. Yeah, taking the example from here, right? This rectangle. Let's say you have a very less data and a very less similarity with the data. So these are the use cases, or these are the approaches you can take to use transfer learning. If your data set is very high, and also if your data is very similar, you can just plug in your new data and fine tune the model. Yeah. Anything else? I guess this sums up the session. Uh, Hello. Hello.
Joinal, can you add your screen?
Yes. Because I got disconnected in between. Yeah. Yes, I guess like this sums up the session. So if there are any questions, I can take. Or else we can call it. Hello. Hello.
Hi everyone. We have our next speaker with us, Gant Labode. He has joined us from US. He is a Google developer expert in machine learning. I would like to hand over the session to him so that he can get started with. Thank you for joining us all the way from US, Gant. Yeah.
Hey, no problem. Happy to be
Yeah.
here.
Yeah. Share your screen.
Done.
Yeah, your screen is visible now. You can start now. All the best wishes for the event.
Awesome. All right, everybody. So one thing I'd love to know is I know that generally every time I talk about AI, I find people know a varying amount about JavaScript and web and cool stuff like that. So I'm going to be talking to you a bit about TensorFlow JS, which I think is a really fun intermediary step between machine learning experts and web developer experts. So in the comments, if you can, please let me know. Are you familiar with web? Are you extremely familiar with TensorFlow, or just kind of getting started with machine learning? And what's great about this presentation is that I am happy to go a little bit longer into the subjects that would be more helpful for you. So please, 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 in the comments, let me know. And you might be wondering, who's this guy? I think that I'm pretty big as an advocate in the idea of doing AI in JavaScript in general. And I know that sounds silly, but trust me, we're going to have a lot of fun along the way. Now, my name is Gant Laborde. I am the CIO of a company called Infant Red over here in the States. And I've been doing React Native development for a long time. React Native, if you're not familiar, is the idea of sort of replacing native development on iOS, native development on Android, native development on Mac, and native development on Windows with one external layer that goes down to the metal if you need it to, and you can write that code if you want, but mostly managing everything in JavaScript. Our company over the past 5 years has found that we can write a single code base that lets us manage a bunch of different platforms just using JavaScript. And then another reason you might be interested in listening to me is that I am a Google developer expert in web and in machine learning. Now, these two worlds intersect perfectly for TensorFlow JS. I'm going to give away a goodie to someone who follows me now. So I'm putting my Twitter handle out. I know you haven't seen my talk, but go ahead and follow me on Twitter now. Why wait? After this talk, I'm going to select someone who followed me, and I'm going to be giving them something that's worth $300 US. So go ahead and follow me on Twitter right now. Sometimes you might see me around Twitter or on GitHub a lot, and I'll look like this. I have lots of cool stickers too. So if you're ever interested in stickers, reach out to me. This is my branding on stickers. So we can get plenty more into my certificates and titles if we need to. But in the meantime, we are here to talk about AI. And I'm going to take a look at the comments real quick. And I think, let's see. I'm not seeing anything about people saying, I'm not sure anybody's having some trouble or anything like that, but I'm not seeing comments specifically on people's experience. So please send those in. Like I said, I'm going to change the conversation to be specifically about that. Oh, so good. Someone's bringing them in. Familiar with TensorFlow and JavaScript? Excellent. Well, Prasoon, maybe you should be showing this presentation. Or maybe this is perfect for you because you've wanted to bring TensorFlow into JavaScript and you're sick of writing expensive backends that go down. So we're all fans of neural networks. We're all fans of AI. And so what we're really looking to do here is bring this to edge devices. And neural networks have been held back for years by the fact that they are heavy. And anybody who was in computer vision in early 2000s knows that you had to write all this information. You weren't using neural networks because it took a lot of time and energy and data. You didn't have GPU access till 2015. And just this idea of this really complex idea of using neural networks was beyond us. And now it is trivial. It is trivial to move a model to an edge device, like a phone, like your websites, anything like that. And so now we are starting to see this new world where these advanced models are becoming part of our offerings and part of websites in a way that we haven't seen before. And I don't know if you're very familiar with that, but actually, I don't know if people are actually enjoying this idea at all. Like, because we're in this virtual world, I'm so far away. So how do I know whether or not you are there enjoying what it is that I'm talking about? And so I thought, you know what? Let's use machine learning. Let's use JavaScript machine learning to try this out. So I have a link for you all, and that is enjoyingthe.show/room/TFUG. So if you can go to this URL, enjoyingthe.show/room/TFUG, then this is going to be fun for us. So I want to know, are you having fun, right? Is anybody actually kind of checking that stuff out? So don't be worried that now what I'm not going to do is this is not a Russian app that I'm going to steal your face or anything like that. What I plan on doing is some faces are extremely hard to read, of course. So what I would like to do here is try some models that are not going to be running on my machine. They're going to be running on your machine. And then they would update me on specifically how you're feeling about this presentation. We don't have to leave this running the whole time. Yes, this does require access to your camera. So please, if you see this, you'll have to have your webcam on if you have a webcam. So I'm going to leave that on for a bit, and then I'm going to come back to it. I see 6 of you are in the room right now that have typed the link. Like I said, the link is enjoyingthe.show/room/TFUG. Let me see if anybody's up. So you're probably seeing your face right now if you're in there. But here's the fun thing that I'm seeing over here is that I have, check this out. Now, can everybody, there you go, smiling for me. Now, I know we're on a bit of a second delay here. Can someone go ahead, just look very serious for a moment if you've got this. Actually, it's probably take a while, but we can see we have 7 people in the room, and I'm getting real-time updates. So if people are smiling and laughing, the cool thing is you can see that it changes as the people's facial expressions are changing. This is just like a cute website. So I'm in the watch room, and so I can actually see everybody from this ID. We have 8 people now. As you change your facial expressions, I get audience interaction from you. So I can see if people laugh, if people get disgusted, or if they get surprised. You can make a surprised face, and it'll immediately update over here. And I think that this is exciting because, now you could build a website to get real-time edge detection. Each of your computers are actually handling the models. None of this is happening. The data that's coming to me is a series of strings, happy, sad, things like that. So as people continue to join the room, you could try this out. If you want to watch, now we've got a split crowd. Some people are smiling, some people are not. And so what we could do here is you can go to watch TFUG, and then you can watch people as they smile and then see the real-time update of what's going on right here. This, to me, is a great sort of application of machine learning on TensorFlow JS. Someone just keeps smiling and unsmiling. I love it. So this is kind of a fun application of that. And I don't have a server that needs to like chug away. The server is just giving me live updates, right? Not hard at all. So a little bit of an exciting concept. I'll take a look at that every so often to see if people are keeping it up and if everybody has some fun facial expressions going as we're chatting. So I'm going to take a quick look again at people's experiences. So I'm seeing beginners. I'm seeing some people who are kind of new to this, and they're saying TensorFlow JS. So I'm gonna cruise on over some of the concepts to excite a beginner, if that's okay, because this presentation can go as deep or not as deep as you like. Like I said, you can go take a course and take all the math and all the certification. You come to a talk to get excited about why you're going to spend that time go taking that course and get that certification, go do all that other stuff, right? So what I want to say is that for machine learning, it's great because it's trained on the data. For instance, if I were to train a spell check in English, and I could either like write all kinds of or grammar check. I could write all that code in English, and then I need to go do it in any other language, Spanish or Polish or whatever language. And the problem is I'd have to rewrite all this code. The great cool part about this is that if I trained it using a set of books, like 10,000 English books, and then all I needed to do to train the same algorithm over here is 10,000 books in that language and 10,000 books in that language, and next one, and next one. Then I have the power to just write one piece of code. And that sort of mentality that I'm talking about right here is why I love JavaScript as an application to machine learning, because JavaScript's like I'm not in love with JavaScript. I don't think it's the best language ever, but it is the most ubiquitous. It does run on Raspberry Pis and websites and drones and everything. It runs everywhere. So the idea of training an algorithm and running it everywhere, and the idea of writing the code and running that code everywhere, I think that we come back into JavaScript. And so why are we caring about this? It's because of the power. And companies like Google have been shoving AI deeper and deeper into concepts. I don't know how many of you have Gmail where you can hit tab and it completes your emails now. It's like building this into the browser, building it specific per client, and then being offline ready. We're looking more and more at cool stuff for JavaScript. So how many beginners do we have here? Let's see. Just a few more. Let's see. I see people smiling in neutral. It's pretty fun. So with AI, I know you've seen that we can do deep fakes. You can see that people are able to try out hair dyes without ever buying this stuff. Imagine a website where you could go to it. Now, this is a phone app from 2019, but imagine you could go to a website and the buy button is right there. As a matter of fact, for a client, we wrote a makeup transfer application. Our friend Leon was trying makeup deep into the night, and he had to write his own WebAssembly to get that model going. One of the cool things I want to say about TensorFlow JS is that if you want your code to be running on WebAssembly, you can do that instantly. How crazy is that? If anybody's written some WebAssembly to really speed up a website, now you could just say, instead of using a GPU backend or a CPU backend, in TensorFlow JS, I want you to use a WebAssembly backend. And then you can get that, what we spent, I want to say, weeks and weeks and weeks to get this makeup transfer working. You can have that right away. It's really cool. So yeah, of course, there's go ahead and dealing with sound. I think it's amazing. Like I'm presenting to you right now. Chris can remove some background sound for me. It could generate music. Google made QuickDraw. If you've been to quickdraw.withgoogle.com, you've seen their drawing. You could basically have AI guess what you're drawing. And they use that, I think, to make autodraw.com, which is really cool. So the web's a great way to grab information from one another. And that's the other aspect I want to kind of identify here. If you want to get information from a bunch of different users, let's say you want to collect non-biased data on, let's say it's paper, rock, scissors. Me, myself, and my friends, I could take some photos and I'll get a few different hands, a few different types. But if I had a web page that had a call to action to get data, I could get pictures of hands from around the world. And that's really cool. So recoloring photos. And then, of course, I like this because I can put it on a Raspberry Pi and see when a parking spot becomes available as well. Of course, with a Raspberry Pi, you could write it in Python, but you could also write it in JavaScript. As a matter of fact, you could just make a web page and run it on a Raspberry Pi, and you're done. So that's how cool it could be. Any of you who are brand new to AI, and I'm going to kind of leave the brand new world of AI. I'm not going to talk about brand new stuff anymore. If you are absolutely new to it, you can go to academy.infinite.red, and you could take my free course and get a certificate. So if you're advanced and you just need some certificates on your resume, you can go there too. There's a 5-day course. It is 100% free, and people seem to really like it. And so that course teaches you some basic terminology of visual AI. That's it. And then you get a cool certificate that you can share on Twitter or LinkedIn or anything like that at the end of it. 5-day course, super easy, really friendly. If you're a beginner or even if you just love having certificates, this is a great opportunity for you. Academy.infinite.red. And I know people love this because I asked AI, and I asked AI in JavaScript. So I downloaded a sentiment analysis model, and then I loaded in all the comments, and then I had it tell me how positive are the comments on my course. And they were ridiculously positive, which I really liked. So funny enough, yeah, I'm not lying. I didn't go to these 5,000 students and ask each and every one of them. I used AI. But not to sound inhuman, I actually do read the comments too. So if you want to reach out to me in the comments, you say, "Hey, I really enjoyed this course," I will read that. So there's a great set of how we can kind of get AI out there a bit more. And I think that what we need to worry about is for beginners, I'll say that don't get too caught up in the terminology. I'm going to skip the portion of this talk that kind of goes into the basics of terminology, because if you've sat here, you've probably heard some of the terms, asked the questions, and kind of figure that part out. If you need some more basic terminology, I suggest take the course or reach out to me on Twitter. I'll be happy to answer some basic questions for people. If you ask me a really advanced question, then it doesn't fit inside of a tweet, I'll have to worry about answering that later. Let me take a quick look. Ooh, I see some happy people again. That's awesome. All right, so now we're going to take a look at getting our models is easy enough, but where do we get this JavaScript kind of world before, right? And so I'd say, like, right now, JavaScript and Python don't play along as well as we'd like. If you're kind of doing things in JavaScript now, you're probably just using these common online services where you're just sending it off to a Python backend, right? Or some kind of other backend. And then you're getting those back, and it's kind of giving you information about what's going on. And don't get me wrong, some of the services that are out there, plus the ones that you have, are amazing. But I think that when you start to build things around microservices too much, you start to lose this capability of being able to really understand what it is that's going to happen. And you start to limit yourself in a certain degree. And that's why I think machine learning in JavaScript is a great way to kind of go about this, because you might say, oh, well, JavaScript's just a toy. Absolutely not. You get access through WebGL to the GPU. So if you're, everybody who was running those models on their machines earlier for smiling and sentiment analysis on their faces, one of the cool things about this is that if you want, if you have a GPU, it was using it. If you don't have a GPU, it was using a CPU. And then this is all spread out across all of those machines for figuring this out. And that really kind of is a huge advantage, because us working together on this, it's not a toy anymore. You could train insane models on this. And so if you're getting involved in JavaScript today, of course, I highly recommend TensorFlow JS, but I do want to mention some awesome other ways to do this. Another great way to do this is Brain. I don't know if you've heard of Brain JS. I have a demo for you that I'll kind of go through real quick. And Brain's a really cool alternative. It doesn't have convolutional networks yet, but it does have GPU access. And then I'd say that one of the cool things you could do is, if you have something specific to a platform, you could still write JavaScript on top of it and access that, like via React Native to native. And so I have examples of that. So let me show you real quick. Here is a simple TensorFlow Lite model. You see it's clicking on the apple, it thinks it's an apple, thinks that's espresso. And then I didn't have tacos not in the training set. So when you click it, it thinks it's a pencil box. But this is JavaScript going down into TensorFlow Lite and then getting an answer and then coming back. This is on GitHub under Gantman/RNs_TF_Lite. You could have all the source code. You could see this exactly how it works. It's very simple. Actually, even used a library to make it happen. And one of the cool things we could do about this is that I'll tweet these slides out later, and then that way you can kind of dig in. You can get all these links as you need to. But get the good ones while you have it. So even though an Android phone is fast on TensorFlow Lite, I still wrote this in JavaScript and was able to access the TensorFlow Lite at lightning speed. So you can still access things specific to a device. Now, another thing I did here, here's 100% JavaScript running on a mobile phone, and this is written in Brain. So here I'm using the classic MNIST data set, where we are drawing on the phone with our finger, and it is identifying what numbers we're particularly typing, and it's running those pixels through the Brain.js model that's sitting on the phone. So this is 100% JavaScript. It could have been a web page, or it could have been a mobile phone app. Either of these would have worked fine, because it's all JavaScript in this sense. And then I'll say, like, as another alternative here, I have this one. You might know of Hot Dog Not Hot Dog. Here's using the Food 101 data set in order to get a live camera view. This is also the same tool I used for my Nicolas Cage detector. I don't know if you've seen that, but we'll go over that in a second. So as you're live using the camera, you can see that I'm hitting the hardware, and this is with CoreML. So with JavaScript, I'm going down to CoreML, and I'm using React Native on this one, so that way I can kind of get the ultimate speed of that device. But honestly, you could use TensorFlow JS as well, and it would be pretty close or comparable speed. So using JavaScript at each of these levels is not even a limitation. Here's 3 different solutions on a mobile device. And you say, like, hey, is JavaScript limited? Absolutely not. This is easy enough. And then, of course, you've got the browser, where I built some fun websites like nickornot.com. Over here in the States, Nicolas Cage is a funny yet famous person. So I made a website that can identify if he's inside of a photo. So the idea here is that if you go to nickornot.com and you upload a photo, it will find Nicolas Cage. That's 100%. It's a silly idea for a website. It's a lot of fun. I did it as a presentation once, but I wanted to kind of share that for you all real quick. And I also have declarationofindependencethief.com, which is a joke website for this. But this is using TensorFlow JS and the Face API library. And then where else can we go with these things? Well, we can use the Chrome plugin. So after doing a lot of these pages, my friend Chris Beekler came to me and said, Gant, I would very much like to build a Chrome plugin that uses TensorFlow JS. And I said, I haven't done that yet. So absolutely, let's do this. Sorry, that's an old photo. And so we decided to go ahead and build this thing. Now, Chris is not a fan of our current president. He's just kind of tired of seeing him. So he wanted to make a website that would take photos of the president and turn them into puppies. So if you go to notrumpsocial.com, we have a Chrome plugin that will watch your Twitter feeds and then just turn photos of a particular person into photos of puppies and sort of brighten your day, because who doesn't need more photos of puppies in their day? I'm skirting around any political conversation on this. It's just a fun project, independent of how people feel about a particular individual. I'm not trying to activate anybody. And then I want to say there's another really fun project that we did that's 100% free and open source called Not Safe for Work.js. I want to say why this project exists. I know this sounds really interesting and weird to some people on why we have that. You might get in trouble for you think, but what I want to say is that big companies have thousands of people who can help protect your content, your user uploaded content. They hire people. Now, people like us, if we do a startup or we have a small group, we can't go manage tons and tons and tons of content. It's like I saw somebody did gun detection in for a bank camera system. And the cool thing about the gun detection for the bank camera system is that a security guard can't look at all the cameras all the time. But if a gun flashes across the screen for a second, AI can catch it and then tell the security guard, we saw a gun, here's the photo, and we saw it in, this room or that monitor. How cool is that? Now you've taken essentially what would take 18 security guards watching all the time and having their eyes dry out and turned it into AI helping people. And I think that that's the same reason we wanted to make Not Safe for Work.js, is that you can't keep looking at all the content people upload. And nor should you. That's a kind of a privacy concern. If I send a direct message to another person, do I want someone checking that all the time? And depending on which person checks it, the results are pretty inconsistent. So that's why we made Not Safe for Work.js, and we made it free. And the idea is, if you don't even know anything about coding, it's wrapped up in an NPM library so that, and by the way, there's no way I'm doing this live. That's why there's an animated GIF. But as you drag these over, it can identify whether an image is indecent or not, whether or not it's something that people should be uploading to your website or checking. And I think what's great about that is you can kind of stop the person before they even upload it. They drag the image into your website and it goes, hey, just as a heads up, this image is getting flagged. We've detected it's a high probability of being something indecent. It's not going live right away. And they're like, oh, I'm going to delete it. It didn't get through, right? So there's a million different ways you can use this. And it doesn't even slow down your servers because it's all running on the client machine. So this is 100% open source. It is 100% free. It is nsfw.js.com. And you can check all that stuff out. I can go into plenty more detail. I will throw this fun tidbit at you. Let me kind of check on people's reactions here. Cool. Awesome. I'm glad people are. I love good feedback. Thank you so much, by the way, everybody who's doing that. I want to throw you a really funny, interesting example of this, where you might see here at the top, I have jeffgoldblum.png. When I first created this model, it consistently thought one of our actors here, who keeps touching his mouth, was pornographic. And so it's bias. Those of you who are new to this, we have this data bias. And those of you who haven't been in this for a while, you might be like, oh, okay, sometimes your model's very wrong in one particular category. That's new to me. That's something you have to watch out for. And the cool thing about this being open source and free and community driven is that usually when a company has extreme bias, it's a terrible, terrible thing. They get in trouble. They go into the news. When we had this bias against Jeff Goldblum, his Twitter account activated and was saying fun and interesting stuff about it. So it actually got more publicity. People contributed, and then we have some photos of that. And so I have to say, because of that, we identified a bias as a community by this being open source in JavaScript, and then we were able to fix it. So now Jeff Goldblum does not categorize as pornography anymore. It's all fixed. Although I'm very sad about that because that was one of the funniest things that were happening with this library. And you can always open up a ticket on bias. Now I have plenty more I can talk about for NSFW.js. I have more slides on how you don't want those things slipping through. It's a little bit more damaging. And so that's the way it's kind of architected. Lots of fun stuff going on there. So like I said, this presentation can take as long or as short as I want. If it kind of fits the audience, I'll dig into that later if we need to. But NSFW.js is free. It is for the community. It is to help you learn how to create code like that. It is to help you in your personal projects, and it's to make you excited about creating cool stuff. So in making models, I'm not going to get into that. Y'all are pretty advanced already, I think, if you know how to make a model. I'm not going to kind of do that. But what I will do is I will show you how to make a model, and this is how it'll close out. Let's make a model in JavaScript together right now. I've seen from some of the talks that you have here that some of you are pretty familiar with TensorFlow already. So I don't think that this will be too limiting to you. And so everybody should see rock, paper, scissors, machine learning in the browser with TensorFlow.js. And here's the URL. Our URL is rps-tfjs.netlify.app. And this is going to train a paper, rock, scissors model on your computer, or you can just sit back and watch me train it on mine. And so that if you know about training, our results are not going to be exactly the same, right? So Lawrence Moroney at Google released this rock, paper, scissors data set with a diverse set of 3D hands. And this is really cool that he did that. And what I did is I took that data set, and if you click on these, it shows you the code that's running here. So this entire website is going to show you some TensorFlow.js running directly in there, and this will show you what's going on. So if I click on this, you can see I wrapped up his data set into this nice class right here called the rock, paper, scissors data set. And then I can just load it, and we can check that out. So if I click this now, it's loading 10 megabytes into my browser of some rock, paper, scissors data set. And then I have this thing that is really cool. It's specific to TensorFlow.js called the visor. The visor is over here on the right side. And using the visor, we are displaying each of those particular hands. And so here's a random set of some hands doing rock, paper, or scissors, just so that you can see the data set came in clean. And you can see I've got RGB rock, paper, scissors hands over here on the right side. And this visor is a great thing. I can actually hit the tilde to open and close the visor while we're doing our training. This feels like an interactive workbook, right? Like I feel like I've recoded in some way the ability of what you normally get with Google Code Lab or anything else. But this is way more interactive, and I kind of like it. So as you can see here, we've got our data set loaded. And now I'm going to click Create a Simple Model. So now that I've clicked Create Simple Model, those of you who are familiar with models, you could see here that I've got a small model here, starting off with a convolution, a max pool, a conv, a max pool, flattening into a dense layer of 3, which is 3 of them for rock, paper, or scissors, so that now I can use softmax to identify which hand is which. If I've thrown out some terminology that you do not follow, don't worry. I just think I'm kind of going in a little bit more because some of you did follow some of the other talks there. So maybe you know some of this terminology. If you don't worry about it. Easy enough to learn those things once you're excited about this. So the simple model is that I created these layers of pretty much looks like, it's like Keras, it's like TensorFlow 2. It is actually standardized on that. I'm just using the sequential models API to add each layer. So here's a layer I want. Here's the layer description. Here's a layer I want. Here's the layer description. I'm basically building in code what you see in this grid right here. So you can see that I've decided I want to do something that looks like the MNIST model. And then I just coded something that looks like the MNIST model. Now, for those of you who are new, yeah, I've created the model. It's untrained. It's dumb. It doesn't know anything right now. So let's ask it some questions. Let's ask it how it knows some stuff. So I'm going to check it. And when I run this, I'm going to go ahead and run the data through here. And you can see it's very wrong. This is called a confusion matrix, and this is a very unhealthy confusion matrix, correct? You can see that things, pretty much everything is scissors. It's predicting scissors all the time. It's rock. It's like 71 times. I say this is scissors. Paper. Oh yeah, that's scissors. And why is it thinking so wrong? It's seen no data, right? Absolutely has no idea what the hell's going on. So let's train it. How do you train this? Well, it's just, those of you familiar with TensorFlow, you'll recognize this code, but I'm basically shoving the data through it. At a high level, I'm taking the data and I'm sticking it through this dumb model. So let's train it. Now, this might look boring for you, and you're like, oh no. Now, how long do we sit around? How is it doing? What's going on? Well, fortunately enough for you, I actually have it outputting the results over in this delicious graph over inside the visor. On each batch, which I think is about 32 images, it's going to give us some results. And once it goes through the entire data set of about 2,600, it's going to give us epoch results. So I'm going to go down to the epoch results. But it's really nice because I can see plenty of these for only a few epochs. And those of you who are familiar want to see our loss function. We want to see our loss go down on the graph, yeah? And we want to see our accuracy go up. And we can see here we have a validation set that's kind of going up as well. So we're not overfitting. So loss goes down, accuracy goes up. After 12 iterations through our data set, we have something that's 97% accurate with 3D hands and a white background. Woo! This thing's kind of smart now, right? So let's check it now. We're going to run the model again, and this is a healthy confusion matrix. This looks good. We labeled it as rock. It said it was rock. As a matter of fact, it didn't get it wrong once. Actually, I'm sorry. I read that wrong. So paper, we said it was paper, and it said it was paper, and it said scissors, it said it was scissors. And you can see here, our big mistake area seems to be when it was actually paper, but scissors, the model thought it was scissors. You can see where our mistakes are. So maybe we need some more examples, or we need to train a little bit longer on paper that kind of looks like scissors. So that way it can kind of differentiate between the two. So now I even have a plan on how to make this model better. And how big is this model? It is 42 kilobytes. That's it. It was a small setup there. And then I could take that 42 kilobytes, bring it over to your machine. And now your machine, without doing any of the training that we just watched, without having to worry about any of this, can immediately and instantaneously identify with 98% accuracy rock, paper, scissors from this data set. Now, remember, this data set's got like white backgrounds and 3D hands. It won't perform as well in your hands. We'll probably have to do a lot more training to do something like that. But this is a lot of fun. So I did do it on my hands. You have to like point the camera up at the ceiling and have no background. So that way you can have a white background. But isn't that cool? We have a healthy confusion matrix now. We've got our trained accuracy. We're seeing it. Wow, scissors is perfect. So this is really awesome. You can see like the scissors, when it's labeled scissors, it got all of them. This is how you read this data. You've probably got way more advanced tools you've already worked with, but isn't this easy? And aren't these graphs fantastic directly in the browser? I feel like I could build something amazing, right? So this was trained, and now that's sitting on your machine, and you could download it. I've got a little example where you can launch your webcam and try to do the code like here. I have an advanced demo where I have a 20 megabyte transfer learned model with object detection. So you can load that, and you can kind of like do it in the screen with rock, paper, and scissors, which is a lot of fun. And lots of other fun stuff. And of course, my contact information for our company and cool stuff that we do. So you just train this. If you were following along, you train that on your machine, and your confusion matrix did not look like my confusion matrix because we all started at a different random, but we all landed on something well over 95% accurate. As a matter of fact, most of us are probably at 98% accurate. And the code wasn't complicated. So now we can easily train directly in the browser. We can train, we can inference, we can kind of build cool things, we can access webcams. You saw earlier, I was real-time watching data as it was trained everywhere else coming in here. Hopefully that's like your brain is saying, I have so many ideas, I could do so much. You can do anything a human would do as long as it was trained with a person was trained with a lot of examples. And that's the part that I think is really cool. We're thinking in machine learning, but we're thinking in machine learning on the web. And so what I think is great about this is that for you to get active on building these things, if you haven't used TensorFlow.js or you haven't done JavaScript, it needs you. We need more examples like this. We need more cool things that people have created. And feel free to use all the examples I've shown today. Please just mention my Twitter handle or give me credit, but use them. Show everybody all this stuff. This is very free and open and available to help everybody else get started. Here's a quote for you. Reimagining everything inspires science. And this quote is by a robot. A robot did this quote. It's inspirabot.me, which has inspirational quotes. So I do have a course that I teach that is on TensorFlow.js. If you are brand new to machine learning and you really want to learn it, that's a course. That's the course I'll be giving away to one of my Twitter followers. You will get to see me teach you everything about TensorFlow.js. We'll go through a lot of the same examples and some new stuff together. If you want to buy the course, this is a coupon code that I only give to people who have watched me talk. So that is Gantt Talks. And so that gives you 20% off. Please don't share that. You have to have sat through hearing me talk in order to get that coupon code Gantt Talk. Don't forget, I have academy.infinite.red. That's old. I actually have 5,000 students now. And then I want to say, just as a few final parts here, I have a Twitter account called Fun Machine Learn, where I just tweet fun and interesting machine learning specific stuff. Definitely, if you want to see more interesting applications of machine learning, go to @FunMachineLearn on Twitter. The hashtag's taking off. And I also have a newsletter that I run that has about 5,000 subscribers, which is AIFYI.com. And if you go there, I will send you an email once a month about what's going on in the machine learning world, sort of in an easily digestible way like you saw today. And I have to say thank you so much to the people at Infinite Red who let me go talk at conferences, who support me through my crazy science experiments. If you need any consulting work, please think of us. If you know anybody who needs some consulting work on either mobile, web, or AI, please send them our way. We pay people who send us work. And I have plenty of stickers. So if we ever meet in person, or if you really need a sticker, go ahead and message me. And this is where you can keep in touch. GantlBoard.com. That is my website. I will be giving talks about all kinds of fun stuff coming up, both mobile and more AI stuff. And then also GantlBoard on Twitter. And with that, thank you, everybody. I love the comments. I love how everybody was so friendly and so nice. It was really cool to virtually come over here and meet so many amazing people. Definitely let me know on Twitter what you liked, what you want to see more of. And with that, that's it. So
Yeah, you have a question from one person. Can I read out to you?
Yes, please.
Oh, yeah. I have a question. I've trained the model on a data set. It gave an accuracy of 95%, but when I trained it on the same data after a week, it was 93%. What
Mhm.
might be the explanation?
Yeah. So if your accuracy here, that's such a interesting. So accuracy as a measurement, right? It's one of our measurements. And so I have to ask, one, were you training it? Did you start over again and train from scratch all over again? If you did, then you can land at different accuracies. Sort of like you saw a moment there, we will never land at the same accuracies, is because the way a neural network is initialized is it depends on the neural network. But basically, I'll just say it this way: it started with a bunch of random numbers. Now, sometimes those random numbers are normalized to fit your data set, and they're fixed in a few different ways. But sometimes they're not, and so that randomness really kind of comes through. So if you retrained from scratch one time, went back again, and then retrained another, then you could have that. The second explanation I'll say, just as a possibility, and I'm not really sure, if um, if your validation set went down in accuracy, then you are overfitting your training set. So if you had 95% accuracy, you're like, train more, get better. And then you ran it for a whole nother week. Then what happens is you're overfitting your actual training set. It's getting so good at the questions it's seen before that when it sees a new question, it starts to fail. And so if this is a number went down on your validation set, then what happened is you're overfitting. Like I said, it's a pretty advanced question. I know it sounds like it should be simple, but check your F1 score. Um, make sure you're constant, are using your validation. If you trained all over again from scratch, then my answer is already set. It's going to be different depending on just even if you don't change a single thing, that initialization function is starting with a different random set of numbers, and you'll find a different local minima. So hopefully that helps out. I'd say there's two paths that you can go there.
So there was a session in MATLAB in the morning. So so the MATLAB people were saying
Yeah.
MATLAB is super fast and all that. So
Yeah.
the person has attended both the sessions. So he has asked a question: if MATLAB is so powerful, then why don't people using JS Python migrate to MATLAB? I'm not
Oh,
sure.
yeah. That's a great question. MATLAB is so. I want you to remember there's two different arms of AI. One of them is specifically going to be your academic, your PhD, your sort of research, and you'll be able to go in and handle any kind of particular difference in there. And it's sort of like having a tower PC. You can go in there, you can play with it, you can modify it, you can do all kinds of cool stuff. And when you need to do that, let's say you're finding one solution, you can build it from scratch. You can do everything that you need to, and you can twiddle each part. Now, generally, you start to do the same thing again and again and again and again and again, and it starts to take a lot of time. So I'd say that over in JavaScript and Python is where you're getting insane speed, best practices, and you are using a framework. So I'd say go to JavaScript and Python for the frameworks, using pandas, using TensorFlow, using FastAI, using PyTorch, of course, is on top. Underneath that. So maybe you want to consume some of the best practices. I say that's a little bit more like the laptop. It comes to you already pressed together, optimized. It's not meant to be opened up and played with nearly as much. So if you're doing something simple like object recognition, I could do it much faster using the best technology in the world over in JavaScript and Python. But if you're trying to do something new and you need to actually get in there and change things, MATLAB's fantastic. But I mean, I don't know how to write GPU accelerated code. I'm not going to start doing that from scratch. I'm not going to start writing, like I've tried to edit GPU access before. It is mind-boggling. I like to use a library where that's all handled for me. So I would say that the way that, and then also, what are you going to ship? You're going to ship MATLAB? I could ship a JavaScript page super easy. So two different form factors, and one of them fits an academic research path, and one of them fits a app path.
So there is another question. So a train model is just 42 KB, but he has made pickle files which were around 10 MB.
Yeah.
He's surprised by that.
Yeah. So this train model is I mean, honestly, it's a small set of weights. So this is an MNIST. It was trained off like the MNIST style. And so if you are training something for MNIST on the classic, I guarantee you're getting small sizes. You can get 10 and you can get 10 megabytes in JavaScript as well. You can get 20 megabyte, 40 megabyte files. It's not hard to go ahead and get larger files. The cool thing about TensorFlow JS is that it has pruning, it has optimization. You can change the weights on them, so that way the floating point values are significant. You can quantize TensorFlow models quite easily. So I've seen 20 megabyte models pop out as 2 megabyte models, no problem, using TensorFlow and TensorFlow JS. The idea of which part of this graph is necessary to keep is, I think, like going to be the future of edge models. So for this one, since we trained something basically using the MNIST model, which is already small, and the size of those numbers are very key. Yeah, 42 kilobytes, absolutely. And it can do a great job with that. And we can get really small models. But yeah, I understand. It's very easy to go ahead and get something that's huge. As a matter of fact, I'll just say this. If you have a non-quantized model, it's 10 megabytes is fair. 20 megabytes is fair. When you're going to web, you want to quantize.
I think we've covered all the questions.
Awesome.
Yeah, thank you so much, Gant, for joining us all the way from US. It must be very early morning for you there.
It is. It's very worth it, though.
Thank you so much, and looking forward to listen to more of your talks. I'll definitely visit your website and course, and I hope all the audience will do that as well.
Awesome.
And, yeah, have a happy Sunday ahead. And I also thank the audience for joining us on Sunday. And if any of the audience is willing to be part of TensorFlow user group Mysore, we are the second biggest community in India. So if you are interested in volunteering, you can reach out to us. And thank you, everyone. And yeah, we are ending the broadcast now.
Hi, everybody. Yeah. I'll see you on Twitter. I'll give away that prize now.
Please do follow Gant on Twitter, and he has shared his code for all the audience who has watched the session, Gant Talk, right?
Yep.
So you can use that coupon to get 20% discount on your honors course. And if there are any consulting opportunities in mobile, web, and AI, you can reach out to Infinite Red, and you'll also be paid a commission if you're sending talk to them. And yeah, thank you so much, Gant, and have a happy Sunday ahead. Thanks, everyone. Bye-bye.
Bye, everybody.
Bye.